Today we will be covering section 5.5, and just being honest, I'm not the biggest fan of how the book covers this section in the way that they explain it. So I'm kind of going off of the Algebra 2 book from last year that y'all had when I teach this material. I just think it makes a little bit more sense. So I'm kind of combining your book and that book a little bit in the notes part itself. I think it'll make it clearer for you, and then obviously I'll do examples out of your homework specifically to try to help you there. So, that being said, we are in 5.5, the law of sines. And you might remember it from last year a little bit, but maybe you don't. It's really easy, honestly, to work with, so I think you'll like it. But what does the actual law say? So the law of sines says that if any triangle ABC with angles A, B, and C, and it is important that these are all capital, they're opposite sides, and these are all lowercase, A, B, and C, respectively. The following is true. Okay, and we can write this law two ways, and you'll see why pretty quickly, but the first way we can write it is the sine of A over A is equal to the sine of B over B is equal to the sine of C over C, or we can just flip it, okay, and you can see that from just these being equal, okay, we can just take and flip both things. So A over the sine of A is equal to B over the sine of B is equal to C over the sine of C, okay, and by that, deciding which one to use is really up to you. I will always put my unknown in the top left, or almost always put my unknown in the top left, because it just makes my multiplying through and stuff easier. And obviously, when you're doing these problems, you're really only dealing with like one set at a time, rather than like this whole thing. You're not going to have all three of these things equal to each other at the same time. You're just going to have a group of like two of them that you're using at a time. So, maybe you remember back to geometry. That was a little while ago. But when you were solving triangles, you had a whole bunch of different theorems that you used for solving sides and angles of triangles. You had things like side, angle, side. You had side, side, side. Angle, angle, side, angle. I can't even remember all of them. But in order to use this, okay, one of the options that we have, or well, two of the options, I guess I should say, for solving triangles of angle, angle, side, and angle, side, angle. So those are two things that we can use this law for. Now, in each of these cases, forms one triangle. And you'll see why I say that in just a minute. Okay, so angle, angle, side, and angle, side, angle, that will only give us one triangle in each case. So the first thing you should check when you're doing these problems is, am I given angle, angle, side, or angle, side, angle? Because if I am, okay, then it only has one triangle. Now, you were probably told as one of the things when you were in geometry, or maybe even last year if you remember, you were told that side-side angle did not exist. Okay, and we have to write it as side-side angle. I'm sure you can see why on your own, okay, but please be careful of that, okay, don't do it on accident. Make sure you always do side-side angle. But this case is a possibility that we can actually have, and it can give us 3 possibilities. We can get out that we have no triangle, that we have 1 triangle, or we have 2 triangles. And I will explain here momentarily how you know. Okay, but just know that this case does exist, okay, and it gives us 3 possibilities. So, possible triangles for the side-side angle case. All right, so consider a triangle. And I'll probably just draw a triangle when I'm talking about it, and you're welcome to do that as well. Consider a triangle in which you are given A, so side A, side B, and angle A. Okay, and these letters can be interchanged, okay? This could be a little c and a big C and a little a here. Okay, it doesn't really matter. But for the purpose of this and what I'm showing you, this is what we're using. Okay, and just understand that this is just for the sake of this example. By fixing side B and angle A, so it means when you draw your triangle, those things are staying where they are, you're not going to move them. We can sketch the possible positions for side A to determine the number of triangles that will be formed. Okay, another important thing here to note is we're looking for, or in some cases we need to find H. H is equal to B sine of A for this given case here. Okay, and with this I mean that B here is the side without the given angle. Or you cannot read that, there's no way. There we go, that should be better. Side without the given angle. Okay, and then this over here is the angle with the given side length. If you can hear those sirens in the background, I guess some fire trucks and ambulances are going by the school right now. Sorry about that. All right, so this means here, okay, we're given this side and this angle. So the angle that we use here is the one that has a matching side, okay? Then this other one is the one that's just by itself. So this is the only B up here, so that's why it's here, okay? So this, And you'll see this more with examples that we do later, but I want to go ahead and make you aware of it, so when I'm doing examples, you're not completely confused. Okay, so now I'm going to start a new page and make a table. So if you don't have probably a good chunk of space, about a quarter to a third of a page, you might want to get out a new page if you're writing down these notes, just because it will take up a good bit of space. So, in your table, okay, on one side we have the case where A is obtuse. Okay, so angle A, still using the same one from before, is obtuse. And that's going to be one column, and there's going to be two within this. And then over here we're going to have four options, and this is going to be when A is acute. Okay, so when A is acute, we have the four options there. So let's start with this obtuse side, get these ones out of the way. Okay, so if angle A is greater than 90 degrees, is what we're talking about here. So my fixed side here is B. We have another just fixed. Okay, we're just saying the fixed bottom portion here, and this angle is A. I made it look like it's a little bit bigger than 90 degrees. So now, in this particular case, and I'm going to try to use some different colors, and hopefully you'll be able to kind of tell the difference in them in this video. I'll do my best to get some different colors. But we're looking for side A, so a possibility here is for A just to be kind of short. Okay, so if we were to take it and we were to draw a string through, okay, it wouldn't intersect down here, it would just intersect over here. And in this case, we say that A is less than or equal to B. Okay, and this should be something that you kind of remember from rules of triangles about side lengths and stuff. But with this, if A is less than or equal to B, there are no triangles. Okay, no triangle is formed. So you would just state A is obtuse, A is less than B, okay, or whatever angles you're using. A is less than or equal to B, meaning there's no triangle. And that's all you'd be required to say for that problem. Now, another possibility under obtuse, okay, I'm going to set it up the same way. So we still have angle A, fixed side B. Another possibility we have is that A could be really, really big. A could be long. So, comes down here. Okay, and this is A. Basically, if we were to draw our string through, and you're probably like, why is she drawing this little imaginary string? It'll come in handy in just a minute while we're looking at a problem. Okay, so it only comes through once, only intersects once. So in this case, we have that A is greater than B. And then in this case, there is one triangle formed. Alright, so those are the two obtuse cases. If angle A is obtuse, or your given angle is obtuse, it can form either no triangles or one triangle. So how about if it's acute? Well, let's see what happens if we have an acute angle. So I'm going to label these 1 through 4 on this side, okay, because then when you're actually doing the problem, you can say by number 1, it's, you know, this is true or whatever. So, number 1, okay, we have an acute angle. So I still have my fixed angle A and side B. Okay, now is where the H's are going to come into play. So let me try to get blue and purple are too close to each other. I'm going to use the big orange here for H. So H here is just this imaginary drop down that makes a 90-degree angle right here. Okay, and the h is that value that we found on the last page. The h is equal to b sine of a. All right, now, our a value could be small again. And it's going to swing through, it's going to intersect that h value. In this case, we say that h is greater than a. And if that's the case, say, okay, so case 1 out of here is that there's no triangle. No triangle formed. Okay? Now, over here, possibility number 2, okay, same fixed side, fixed angle. Another possibility we have, with our h being dropped down, is that a could be right along that line. So when it swings through, it only swings through in that one spot there. Okay, so it barely touches in this one spot. Ignore this little part here. It swings through in this one spot, hits once, and that's the only place that it hits. In this case, we would say that h is equal to a. I should write in this is an h there. Kind of a blob, sorry about that. Alright, so h is equal to a. Then, well, you can probably tell, but this forms one triangle. So now, the next case, case 3, set up the same way. The a, h is a drop down here. Now, if a is long, but not super long, okay, a possibility is that it intersects over here somewhere. Okay, and this is where that imaginary string is going to be important. Because what happens is we take this and we swing it around, and what ends up happening is it intersects again over here, making another possibility for A. Okay, and this was a little bit dramatic here, but you get the idea. Okay, it intersects at 2 points, meaning, in this case, H is less than A is less than B. Okay, so A is smaller than B, but H is smaller than both of them. So in this case, we end up with 2 triangles. In our last case, okay, and let me pause for a second. With these, okay, this right here is what gives you your number of triangles, and that means you actually have to solve for 2 separate triangles. Okay, and we will do an example of that as well. Let's see, number 4. So the last possibility here, with H being dropped down, okay, A could be really long, okay, and be way out here somewhere. So the point that if you swung it through, it wouldn't intersect back over here. So in this case, A is greater than or equal to B. And you could do this one without ever finding H, because if A is greater than or equal to B, that's the only case where that's true. You could immediately say, there's one triangle, and if you were asked to solve for it, then you could solve for it. So this right here is the important list. Okay, this is how to do these problems, how to set them up, and all of that. what I think I'm going to do is we're going to stop this video here, and then you'll go to a separate video to watch the examples that go with this. So the link for that one will be attached with this one as well.